Good afternoon, class. We are looking at pre-calculus practice test number 5, covering chapters 10 and 11. Here's chapter 11, sequences and series. Again, I want to remind everybody that before starting the exam, please read the following pledge aloud. I pledge on my honor that I will neither give nor receive unauthorized assistance, so on and so forth. In short, you take the exam on your own and no one else. Having said that, let's go with module 5, sequences and series. Write the first 5 terms of the sequence. A sub n equals 9 times 1/4 to the power of n minus 1. So first and foremost, what is a sequence? A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, all the way to a sub n. First, second, and the nth term of the sequence. Accordingly, a sub n is the general term, and n being the set of positive integers, 1, 2, 3 to infinity, or natural numbers. A series is the sum of the terms of a sequence. So in this case, we want the first 5 terms, we start with 1, and so we're going to replace the n with 1. Obviously, that's 0. 1/4 to the power of 0 is 1, and you get 1. So 9 times 1 is 1. And we replace it with 2. This is 1. That means 9 times 1/4 is 9/4. And of course, you can do the rest of them, and we get the other 3 terms in the same manner. As you may notice that it's being multiplied by 1/4 to get the exponent, so on and so forth. Now, for the sequence, a sub n equals 2, a sub n minus 1 plus a sub n minus 2, where a sub 1 is equal to 6 and a sub 2 equals to 3. You want to find the first 5 terms. And again, let me remind you, a difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence, a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equations. So with that being the case, we have the first one, we have the second one, so we have a few more to go. So write the general format, and since we have the first and the second one, we want number 3 here. So if this is number 3 and this is n minus 1 must be 2, and this is n minus 2 must be 1. That's what it means. Okay, it's very straightforward, everybody. So a sub 3 is 2, a sub 2 plus a sub 1, which means, if you look at this one in general, it means if you want any term, go to the previous one multiplied by 2, and then add the one before that. So if I want a sub 3, I go to the previous one, a sub 2, I multiplied by 2, and add the previous one. Therefore, 2 times 3 plus 6, they add up to 12. Now, again, in the same manner, if I change this to 4, this becomes 3, this becomes 2, or just take a look at this one. This is a sub 3, a sub 4 is 2 a sub 3 plus a sub 2. And that means 2 times 12 plus a sub 2, which is 3. 24 and 3, 27. And I'm going to assume you can figure out the last one on your own in the same manner. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. And so I want to remind you, arithmetic sequence, recursively a sub n plus 1 is a sub n plus d. Explicitly, a sub n equals a sub 1 plus n minus 1 times d. D is the common difference or distance. In other words, in the case of arithmetic sequence, if you want any one of those to be found, okay, if you want any term, you go to the previous term and you add some constant number. So that would be recursively. Or in general, a sub n is a sub 1 plus n minus 1 times d. So that's how you find different terms. In the case of a geometric sequence, recursively a sub n plus 1 is r times a sub n. Explicitly is a sub n equals a sub 1 or to the power of n minus 1, or is a common ratio. So again, this means if I want a term, I can go to the previous one and multiply it by a common ratio. That's the concept. So having said that, if you want to check something to see whether it's geometric or arithmetic, for arithmetic, see if you can add a constant. For geometric, if you can multiply by constant. So we're going to divide this one by this one. And then you're going to divide this one by this one by this one. And if they give you the same answer, 0.25 over negative 0.125 is negative 2. And this is a sub 2 over a sub 1. Okay, so let me just write a sub 1, a sub 2, a sub 3. And then must be the same as a sub 3 over a sub 2, and it is. So R must be negative 2. By the way, if you have doubts, you have to check it further, meaning the next one and the next one, 1 over minus 0.5 and so on. What about this one? 8 divided by 6, is it equal to 11 over 8? No, and by the way, this is A1, A2, A3, so this means 8 over 6. This means 11 over 8. And one way to see whether they are equal or not, if the cross product is equal, and it's not. Also, look at the difference. The difference, A2 minus A1 is not. So 8 minus 6 is 2, 11 minus 8 is 3, so it's neither nor. It's not an arithmetic sequence, it's not a geometric sequence. This one, let's divide 1/2 by negative 2 and then negative 1/8 by 1/2. So this one, 1/2 over negative 2. This is A1, A2, A sub 3. And this is negative 1/4. Now let's divide this one by this one. Negative 1/8 over 1/2, that is also negative 1/4. And R is negative 1/4. We are dealing with a geometric sequence. Write the arithmetic sequence 32, 24, and so on in the standard form. That means find A sub n. And again, this is the arithmetic sequence. A sub 1 is 32. The difference between the two is minus 8, because 24 minus 32, 16 minus 30, 16 minus 24, that would be negative 8. So the first term, A sub 1, their difference is minus 8. So A sub 1 is equal to A sub n equals A sub 1, which is 32, plus n minus 1 times d, which is negative 8. You get minus 8n plus 8. These two add up to 40. A sub n becomes minus 8n plus 40. All right, fill in the blank. 139 is which term of the arithmetic sequence 1, 4, 7? So they are telling us it's an arithmetic sequence. You should always check it. The first one is 1, and then 4 minus 1, 7 minus 4, 10 minus 7, all of them are 3. So we're going to write A sub 1 and D. And A sub n has the general formula A sub 1 plus n minus 1 times D. And so we're going to replace the A sub 1 and we're going to replace the D. So we get 1, and we're going to distribute plus 3n minus 3. Obviously, 1 and minus 3, they add up to negative 2. Okay. Now, which term is 139? I don't know. Let's set this equal to 139. When we do that, negative 2 moves and it becomes positive 2. 3n is 141. Divide by 3, and you get 47. So it's the 47th term. Or put that into this, it must give you 139. You can check it that way. All right, find the formula for the general term A sub n of the sequence, assuming the pattern of the first few terms continues. We have 0 0.8, 4, 20, 100. So we notice the first one is 0 0.8, okay, and we want to find A sub n, okay. So let's see if it's an arithmetic sequence, a geometric sequence, so we can look at their difference and their ratio. Obviously, 4 minus 0 0.8 and 20 minus 4 are not equal. Let's look at 4 over 0.8, 20 over 4. 4 over 0.8 is the same as 40 over 8, the same as 20 over 4, and it's 5. Therefore, you're dealing with a geometric sequence. And so A sub n is A sub 1 or to the power of n minus 1. We want the eighth one, A sub 8. Replace the n with number 8. So we get A sub 1, which is 0 0.8, okay, times 5 to the power of n minus 1. Replace the n with 8. So it's 0.8 times 5 to the power of 7. Put it into a calculator, you get 62,500. So that's pretty straightforward, everybody. Now, find the ninth term of the geometric sequence whose initial term A sub 1 equals 4, and the common ratio is 2. So we use the formula A sub n equals A sub 1 or to the power of n minus 1. A sub 1 is 4, R is 2, n is 9, just plug in. So we get A sub 9 equals 4, 2 to the power of 8. 9 minus 1 is 8. And put it into a calculator, and you get 1024. 1024. It's very straightforward, everybody. It's simple. We want to evaluate the summation of k squared minus 1 from 3 to 7. I hope you remember the meaning of this sigma, the summation. So basically, you start from the first number that you have here. The limit starts from 3. So 3 squared minus 1. Then you go to the next number, 4. So plus 4 squared minus 1. 5 squared minus 1. 6 squared minus 1. 7 squared minus 1. Add them all up. That's the meaning of summation. 9 minus 1, 16 minus 1, 25 minus 1, 36 minus 1, 49 minus 1. And add them up, you get 130. So the concept of a summation, sigma simply means add them up in the fashion that was explained. Now we want to write the arithmetic sum. 9 plus 4 plus negative 1 all the way to negative 26. I'm reminding you this is the arithmetic sequence. And so, excuse me, we are going to write the summation of n going from 1 to n, a sub n. We want to find a sub n, and that's what this means. This is the first one, the first term, a sub 1. Their difference, 4 minus 9 is negative 5. Minus 1, minus 4 is also negative 5. We are checking, okay? So the first term is 9, and d is negative 5. So we can find a sub n using a sub 1 plus n minus 1 times d. So plug in. Now this is minus 5 and this is plus 5. 9 and 5, they add up to 14. So A sub n is minus 5n plus 14. Now, we stop at negative 26. So this would be for this set, the nth term. We can find the value of n by setting this one equal to A sub n equal to minus 5n plus 14. Subtract 14 and we get minus 40. Divide by negative 5, n is 8, meaning this is the eighth term. We just are showing that where we stop, what term it is, n equals to 8. The summation of n going 1 to 8, A sub n, which is this one. So we are showing this with the sigma notation. Sigma means sum them up, add them up. We want to evaluate this summation from 1 to 14, 3 times to the power of n minus 1. So we have to just add them up 3 times. 2 to the power of n minus 1. That means 1 minus 1 or 0. So that's 3 plus the second one. 3 times 2 to the power of 2 minus 1 or 3 times 2. Let me just quickly show you that. So this means 3 times 2 to the power of 0 plus 3 times 2 to the power of 1 plus 3 times 2 to the power of 2 all the way to the end. Now, of course, this one is 1, so this becomes 3. This one is 2, this becomes 6. This is 4 times 3 becomes 12. You just have to add them up. Now, S sub n, the summation of the first n terms of a geometric sequence, has the formula A sub 1 times 1 minus r to the power of n over 1 minus r. Now, this is a geometric sequence because this is the first term, and then we multiply it by 2. That means r is 2, or you can say 6 over 3 or 12 over 6. So we're going to follow that formula. Replace the A1 with 3, R with 2, here and here. And n is whatever number this one is, 14. Now, obviously, the denominator is negative 1. You have to calculate 1. You have to calculate 2 to the power of 14. Okay, 1 minus that times 3 divided by negative 1, and it becomes 49,149. As you can see, it's a pretty large number. Okay, so we have to be going through the process. In this case, S sub n to come up with the answer. Find the partial sum, S sub 11. The reason they say partial because we stop at some point. Okay, otherwise it's an infinite sum. S sub 11 for the arithmetic sequence, A sub 1 equals 9 and D equals 3. And for arithmetic sequence, the sum is n over 2 A sub 1 plus A sub n, or n over 2. If you replace the A sub n, you end up with 2 A sub 1, A sub 1 plus n minus 1 times D. And if we look at what's given, we have A sub 1 and we have D, and we don't have A sub n, so we're going to use this formula. So n is 11. We want S sub 11, 11 over 2. 2 times 9 plus n, again, is 11 minus 1 times D, which is 3. So this is 11 halves, this is 18, this is 10 times 3, 30. So it's 48. This cancels this one. 24 times 11 is 260. So pretty straightforward, everybody. We're going to move on. Find the infinite sum, if it exists, for this geometric sequence, series -2 plus 0.5 plus negative 0.125, so on and so forth. So what I want to add, as far as the, any series for that matter, when you add them up, if you add them up indefinitely all the way to the end, becomes an infinite sum. Now, if you are calculating this infinite sum, you may not have an answer because it just gets larger and larger without bound. However, if R is between -1 and 1, as n gets larger, R to the power of n gets smaller. Okay, just quickly to show you this concept that I'm referring to. If I have 5 and I square it, becomes larger. But if I have 5 and I square it, becomes smaller. So if I raise it to the power of 3, it's even smaller. Okay, so that means if this is the case, this goes ultimately to 0. So the numerator is a1 times 1, or a1 over 1 minus r. And this is if the ratio is somewhere between -1 and 1. So you want to find, the first one obviously is -2. You want to find r. And to find r, divide 0.5 by -2. Also, you really have to, let me erase my work. You really have to check, just in case, divide this one by this one by this one, and check that it's correct. It's -1/4. Because R is between the two, we are going to use S sub infinity. The infinite sum is a sub 1 over 1 minus R. Okay, and we can plug in. So this is -2. This is 1 minus 1 over 4. This is plus, becomes 5/4. And -2 divided by 5/4. You can put the 1 underneath and say this is -8 over 5. And that's the final answer. Okay, very straightforward, everybody. All right, we want to do this, and we are looking at the sum, and this is an infinite sum. And this is a geometric series because we're adding them up. Sequence becomes a series. If you don't see, just write the first few. For example, if I say k is 1, 1 minus 1 is 0, I get 9. If k is 2, 2 minus 1 is 1, so I get 9 over 4. If I put 3, 3 minus 1 is 2, 1/4 to the is 1 over 16 times 9. So I hope you see that the first term is 9 and r is 1/4. Therefore, I can use this one. Let's plug in. A1 is 9, 1 minus r is 1/4. 1 minus 1/4 is 3/4, and 9 over 3/4. It's a complex fraction. It's not a big deal. 9 over 3/4. You can do this. Put 1 here. 9 times 4 over 3 times 1. There it is, 6 divided by 3. That is 12, just to show you heights. calculated easily in case. On each swing, left to right or right to left, a pendulum travels 90% as far as on its previous swing. If the first one is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. All right. So what I want you to notice is that this is a geometric sequence because, well, this is R, everybody, 90% or 0.9, and this is 10 feet, A sub 1, the first swing. So this number is R, and this number is A sub 1. And by the way, in some texts, they just use A over 1 minus R, which represents the first term over 1 minus R. So we are going to use the formula as mentioned. Replace the A1 with 10 and 1 minus R with 0.9. Obviously, 1 minus 0.9 is 0.1, and 10 divided by 0.1 is 100, and the units in feet, which means it takes about 100 feet for it to stop. It's fascinating. A ladder consists of 31 rungs if the rungs taper uniformly 18 inches to 28 inches. So they taper. How much material would be needed for the 20th rung? So first, what are we talking about? So we're talking about a ladder, okay? We have 31 of those. 1, 2, 3, 4, 5. This is obviously just an example of a ladder, okay? And it goes from smallest one, which is 18, to the largest one, which is 28. And because it tapers off, uniformly, you can use the arithmetic sequence because we are adding or subtracting a constant. That's why. So having said that, what do we have? We use arithmetic sequence. N is 31, A1 is 18, A31 is 28, and what is A20? So we need to figure out how to solve this. That means we need to figure out what is the value of D, and we're going to go through that in a moment. But again, understand, 31 is total N, 18 is A1, and 28 is A sub N, more specifically, the last one, A sub 31. And now they're asking for A sub 20. So the formula for A sub N is here. We're going to use that. And the fact that A sub 31 and A sub 1 is known, we can find this one, A sub 31 is A sub 1 plus N minus 1 D, okay? So A sub 31 is A sub 1 plus 31 minus 1 times D. A sub 31 is 28. A sub 1 is 18 plus 30D. Subtract the 18 from both sides. You get 10 and divide by 30. And you get D equals 1/3. So what is a sub 20 is a sub 1 plus 20 minus 1 times d. So a sub 1 is 18. 20 minus 1 d, we found it to be 1/3. So we get 18 plus 19 times 1/3. This is 6 and 1/3. 6 and 18 is 24. 24 and 1/3. And the units, the same units as those, 24 and 1/3 inches. How much material would be needed for all of these 31 wrongs? We can use any of those formulas. Since we have the a sub 1 as well as a sub n, we're going to go with that formula. So n is 31. So we want s sub 31. 31 over 2, 18 plus 28. 18 and 28 is 46. 31 times 23, 713 inches. That is the total material we need for 31 wrongs. A factorial symbol and binomial theorem, if n is larger than or equal to 0, and it's an integer. The factorial symbol n factorial is defined as follows. 0 factorial is 1, 1 factorial is 1, n factorial is n times n minus 1 times n minus 2, all the way to 1, and n is larger than or equal to 2. Which makes n factorial the same as n times n minus 1 factorial. So you can stop at any time you want and do it that way. For example, if I want to simplify 12 factorial and 10 factorial, because 12 is larger than 10, I'm not going to touch the 10 factorial. But this one, according to this formula, I can write 12 times 11, and I stop at 10 factorial. Please understand, this is the same as 10 factorial. So you keep the smaller one, 10 is less than 12. Therefore, they cancel each other. The answer is 12 times 11, which is 132. That's how you simplify it. Combination of n elements taken R at a time. A subset of items selected without regard to order is called a combination. A combination of n elements taken R at a time with R less than or equal to n is denoted by CNR in this format, or parentheses NR, or C parentheses NR, and it's sometimes read as n choose R. It's n factorial over R factorial times n minus R factorial. Note, order within the group of R object is not important. How many different committees of 3 people can be chosen from a group of 8 people? Well, a committee is an unordered set, the arrangement of people, therefore order is not important, therefore you can use combination. So C83. So how do we calculate that? First of all, according to this formula, n factorial, that means 8 factorial at top, then R is 3, and then 8 minus 3, 5 factorial. So if I want to simplify this without using a calculator, it's very simple. The larger factorial is 5 factorial at the bottom. I'm going to keep that. I'm going to change the 3 2 times to 3 times 2 times 1. And I'm going to change this 8 times 7 times 6, and I stop at 5 factorial. These two canceled. Three times 2 equal to 6, so the answer is 8 times 7, or 56. Is pretty straightforward, everybody. Now, what if I want to use a calculator? Permutation. If the number gets involved, you can use it. TI calculator for permutation and combination. Enter the value of n, then press math, then select PRB probability, NPR or NCR. This is for permutation, and then enter the value of R. For example, we go with PRB and we go with NCR because we want a combination. And so 8 NCR3 is 56. So that's pretty straightforward, everybody. So NR, CNR, ANR in this format is n factorial or factorial over n minus R factorial. Assume 8 people enter a swim competition. In how many ways could the gold, silver, and bronze prizes be awarded? Well, order is important. So here's what happens. A permutation of n elements taken R at a time is one of the arrangements of R elements from the set of n elements. If P and R in this format or in this format denotes the number of permutation of n elements taken R at a time with R less than or equal to n, then P and R is n factorial over n minus R factorial. Note order within the group of R objects is important. So it makes the difference whether you're the first or the second or the third one. That's why order is important. And therefore, this is a permutation of 8 people taking 3 at a time because order within the group is important. You're not just picking 3, more specifically, which one is number 1, which one is number 2, and so on. So it's the permutation of 8 choose 3. So it's 8 factorial over 8 minus 3 factorial, which makes it 8 factorial over 5 factorial. Now, you could, again, I want to show you both, because you can say 8 all the way times 1 and 5 all the way times 1. But like I said, I've shown you before, I wouldn't do that. I'm going to keep, this is 5 smaller than 8. I'm going to keep the 5. And the top is 8, 7, 6, 5 factorial. So I can cancel those two. And it's 336. So it's pretty straightforward, everybody. Now, as far as calculators go, we are going to go with PRB and NPR. And in this case, N is 8. And then we put 3 and we get the number 336. In other words, the calculator can do the job for you. But so for large numbers, you can always use a calculator. Okay. That's the idea, everybody. Binomial theorem. X plus a to the power of n is the summation of r going from 0 to n, combination of n choose r, x to the power of n minus r, a to the power. Notice the exponents must add up, n minus r and must add up to this number n. And now what is c and r? N factorial over n minus r factorial times n minus r factorial. So x to the power of n minus r, a to the power. In the general format. So what happens? The first one, you replace the r with 0, okay? And so this is n factorial, okay? Over n0 x to the power of n a to the power of 0, n1 x to the power of n minus 1 a1, all the way to the last one, n x to the power of 0 a to the power of n. So that's the general format. Couple of those that we have seen. For example, a plus b squared, everybody knows a squared plus 2ab plus b squared. That's binomial theorem when n is 2. A plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. That's a binomial theorem when n is 3. Now, these two, the first one and the last one, you can show that they're 1. N choose 0 and n choose n is 1. This one, n choose 1 is n. And n choose r is the same as n choose n minus r. So first of all, what I mean with the last one, as long as these two numbers add up to n, r and n minus r add up to n, that's the case. Just so I want to discuss the last one first. Example, let's make up some numbers here. Okay, we are saying that this is, let's say number 3. Then what should I put here? 10 minus 3. That's the idea behind this. Okay. Now, n0 and n, for example, n0 would be n factorial over 0 factorial, n minus 0 factorial, which becomes n factorial over 1 times n factorial, and it's equal to 1. And you can prove the rest of them in the same manner, okay? It's really a good idea to remember all of those, because when we want to evaluate and use binomial theorem, it helps. So for example, we want to use the binomial theorem to expand 3y plus 2 to the power of 4. And again, the binomial theorem is given here, and I'm going to remind you. For non-negative integers n and r with r less than n, x plus y, you can use any variable here, okay? So x plus y, a plus b, it doesn't matter. So x plus y to the power of n is summation r going from 0 to n of n choose r, x to the power of n minus r, y to the power of r. So n choose r is n factorial, r factorial times n minus r factorial. This is the combination, and those two don't change. And when you expand it, this is what you get, x to the power of n, because as I mentioned, the first one is 1, and so is the last one, by the way. This one is n1, which becomes really n. This n2 you have to calculate, and so forth. Okay. 4 useful formulas was mentioned the previous page, Cn0 and Cnn is 1. Cn1 is n, and Cnn minus 1 is equal to n, nr, and n minus r. They are identical. So it's just making sure that you understand they are the same. So having said that, let's go with number 4 here. And so the first one is 4, 0, 3y to the power of 4. The next one is 4, 1, 3y cubed times 2, and so on. So we are following this format. So 4, 0, 3y to the power of 4. First of all, 4, 0, 4, 1, 4, 2, 4, 3, and the last one is 4. Secondly, the first term to the power of 4, and the next one to the power of 0 is 1. Then the first term to the power of 3, you go down by 1, and this has exponent 1. See, when the exponent is missing, the exponent is 1. These two add up to n, which is 4. Then you go with this one, 4, choose 2, 3y squared, 2 squared, 4, choose 3, 3y times 2 cubed, and 4, 4 to the power of 4. Now, it's important to calculate those, okay, in the following manner. First of all, 4, 0, and 4, 4, both of them are 1. We should know that. These two are the same, 4, 1, and 4, 3 are the same, and 4, 1 is 4. So again, 4, 1 is 4, and 4, 3 is just like that because of n, or choose r from n, and in this case, n minus. So the only thing you have to calculate is this guy. Let's calculate it. 4, 2 would be 4 factorial over 2 factorial times 4 minus 2 factorial, which is 2 times 2 factorial, and I'm going to leave it for you to show that it's 6. I'm going to erase my work. So this is 1, and this one to the power of 4 is 81, y to the power of 4. This is 4 times 2. This is 3 cubed, 27, y cubed. This one, 4, 2, we showed it's 6, times 2 squared is 4, and this is 3y squared, or 9y squared. 4, 3 is also 4, It's the same as 4, 1. 3y times 2 cubed, that means 8 times 3y. And 4, 4 is 1, 2 to the power of 4 is 60. That's it. Now, this is going to be 81, y to the power of 4. This is 4 times 2 times 7 is 216 y cubed. 6 times 4 times 9, 216 y squared. 4 times 8 times 3, 96 y, and a 16, and you're done. So I hope everybody is comfortable with the binomial theorem. So you want to make sure you know what this is. Now, a different type of question might be find a specific term, in this case, 7th term in the expansion of y plus 3 to the power of it. You have two choices. You can just expand from A to Z and then say number 1, number 2, number 3, and count it, and number 7 is the answer. You can always do that. There are also easier ways. I'm going to go over them too. So one way, just expand it if you don't want to learn this and count. However, what is the rth term of a binomial expansion? X plus y to the power of n is summation r going from 0 to n of n. Choose r, x to the power of n minus or y to the power of r. And here's the combination instead of nr, n factorial over r factorial, n minus r factorial. The rth term of the binomial expansion x plus y to the power of n, where n is larger than r minus 1, is n over r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. The term containing x to the power of j would be n, choose n minus j, x to the power of j, y to the power of n minus j. And of course, the combination. Again, you can memorize that or not, but for this one, obviously n is 8, r is 7, x is y, and y is 3. X is y and y is 3 because we put x plus y here, right? And so with that being the case, we write n over r minus 1, x to the power of n minus r minus 1, y to the power of r minus 1. So n is replaced with 8 and r is replaced with 7. So that's one way to do that. And of course, this is 6 and this is 8 minus 6. Okay, that's 2 and this is 6. But I want to show you a second method that actually makes it a lot easier. And that is, we know y plus 3, 8 follows this formula. Summation of 0 to 8. So just write down 8 factorial over r factorial 8 minus r factorial, y to the power of 8 minus r, 3 to the power of. We are looking at this formula, I believe. Now, we know the first term, if we expand this, the first term, r is 0. Second term, r becomes 1, so on and so forth. So seventh term, r becomes 6. So for the seventh term, here, replace the r with number 6. So let's see what we get. 8 and r is equal to 6. 8, choose 6. Y to the power of 8 minus 6, 3 to the power of 6. I thought I put that 6. By the way, 8, choose 6 or 2, they give you the same answer. That's why it's 2 here. But in any event, now you expand this and you get 8 factorial over 6 factorial times 2 factorial. This is y to the power of 2. This is 3 to the power of 6. And that's exactly what you have here. And this one, we're going to say, since this is 6 factorial, we're going to keep it. The bottom is 6 factorial. 2 factorial is the same as 2 times 1 or simply 2. And 8 factorial is 8 times 7 times 6 factorial. You raise this to the power. This 6 factorial here and here cancel each other. 8 times 7 divided by 2 and times 729y squared gives us 20,412 y squared as the final answer, everybody.